Today I'm going to give you some more information on geometric series. Today's the 16th. Or on geometric series. In the last video, we just had series already expanded out and we were finding the values of them. But what if it's written in sigma notation? What we're going to do is we're going to take a look at some sigma expressions, and let's say our index is I, so I is equal to some lower number up to some upper number. And if you have a geometric series, then you're going to have whatever the R value is raised up to the I, or sometimes this is raised up to the I minus 1 power. So the number of terms in this series is equal to upper minus lower plus 1. So that's your n value. And the R value is always raised up to the index, or the index minus 1. So let's take a look at some examples, and we'll see why they're actually geometric series. And then we'll use the formula that we learned for geometric series. Let's say I is equal to 1 up to 4 of 3 raised up to the I power. Well, we know this is a geometric series because we have the base of 3 raised up to the I, the index power. So since this is geometric, we can use the formula for the sum. We have 4 minus 1 plus 1 is 4. So we have to sum the first 4 terms in this series. So the sum is A1, which is 3, times 1 minus R to the n. Well, the R value is equal to 3 in this case. So it's 1 minus 3 raised up to the 4th, all over 1 minus 3. And with no calculator, we should know that 3 to the 4th, or figure it out anyways, is 81. So we have 1 minus 81 over negative 2. And 1 minus 81 is negative 80. So it's 3 times negative 80 over negative 2, which is 3 times 40, which is 120. So there's that first example of a geometric series written in sigma notation. Let's just do one more example. Let's say I is going to start at 0, and we'll go up to 4 again. And let's say we're going to have 2 times 1/2 raised up to the I power. Anytime you have a coefficient out in front of your R value raised up to the I power, this can always move out front. So that's what I usually like to do, is I like to move the 2 out in front. So it's 2 times 1/2 raised up to the I power, and I is equal to 0 to 4. This time n is equal to 5. We have 5 terms. And the first term, A1, is equal to 1/2 to the 0, which is 1. So the first term is 1. So the sum of the first 5 terms of this series is equal to, and we can't forget our 2 on the front, 2 times A1, which is 1, times 1 minus R to the n, 1/2 to the 5th, all over 1 minus 1/2. Which is 2 times 1 minus 1/2 to the 5th is 1 over 1/32, and 1 minus 1/2 is 1/2. And when you're dividing by 1/2, it's the same thing as multiplying by 2. So this is 2 times 2, which is 4, and 32 over 32 minus 1 over 32 is 31 over 32. And this can reduce down because 4 over 32 is 1/8. So the answer to this, is 31 over 8. So these are finite series. You can actually sum an infinite geometric sequence. You can sum an infinite geometric sequence, which is called an infinite geometric series. Some infinite geometric series actually can be computed. And some just go to infinity. For example, if you have this infinite geometric series, 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus, you can see that all of these numbers get bigger and bigger and bigger. And if you add them all up, you'll never reach a final number. It actually goes to infinity because the numbers just keep getting bigger and bigger. But if you have the opposite geometric series, which is 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4, and on and on and on. You can see that these numbers get smaller and smaller, and eventually, if you go all the way out to infinity, you'll get 1 over a very large number, and you can almost imagine that this is like 1 over infinity, which is actually equal to 0. So this theoretically will end at some point, and you can add up all of these numbers, and they actually will reach a certain finite number. So this is an infinite geometric series that will diverge because it just gets bigger and bigger and bigger all the way to infinity. But if you have a geometric series that keeps getting smaller and smaller and smaller and smaller, then this geometric series actually converges to a particular number that can be computed. And we have a formula for that. And the notation is the sum of an infinite series is A1 times 1 over 1 minus R. And this is actually, you can get this from a finite geometric series, because a finite geometric series is 1 minus R to the n over 1 minus R. And this will converge if the R value is less than 1. So in this example up here I gave you, this R value is equal to 1/2. So this converges. But this sequence right here, or this series, the R value is equal to 2. And since 2 is greater than 1, this keeps getting bigger and bigger and bigger, so this diverges. So you can use this formula to find the answer to an infinite series as long as r is less than 1. So in my example here, starting with the 64, if I wanted to figure out what that value actually approached, this infinite series is equal to a1, which is 64, times 1 over 1 minus 1/2, which is 64 times 1 over 1/2, divided by 1/2 is multiplying by 2, so this actually is equal to 128. So if I added all those numbers up all the way to infinity, I'd get 128. So let's take a look at what this looks like in sigma notation, an infinite series. Let's say we're asked to sum from n is equal to 0 to infinity of 2 times negative 1/4 to the nth power. Well, the sum of an infinite series is equal to a1 times 1 over 1 minus r. Now, if you remember from a couple minutes ago, this r value is equal to negative 1/4. The first term of this series is when you substitute n equals 0, you have 2 times negative 1/4 to the 0, which is 1, so 2 times 1 is 2. So this value, the first term is 2, multiplied by 1 over 1 minus a negative 1/4, which is 1 plus 1/4, which is 5/4. And if you divide by 5/4, it's the same thing as multiplying by 4/5. So this is 2 times 4/5, which is 8 over 5. So this infinite series actually converges to the number 8 over 5 because this r value is less than 1. On the other page, you need to update this. I said this will converge if r is less than 1. You should put in the absolute value of r, because if r is like -2 or -3, it's going to diverge. So this has got to be something between -1 and +1. And let's look at one more example of an infinite series. Let's say we have n is equal to 1 to infinity of 3 times 2 to the n minus 1. Well, right now we can see that r is equal to 2 because this number is raised up to the index. So this infinite series will diverge. So we don't use that formula because it actually just goes to infinity. Infinite series is a really important concept when you get to calculus class. So hopefully you'll see that this formula is really important for you to memorize this year because you're going to be using it in calculus next year. And so I think that's it for today.